A picking interface seamlessly connecting passive and active performance on guitar. We have designed an interface that allows a guitar player to manipulate another channel, such as the manipulation of sound and visual effects. Passive performance refers to a state in which the performer normally plays the guitar, and the interface automatically applies sound and visual effects. On the other hand, active performance refers to a state in which the player actively manipulates the effects through the interface when the player is not playing the guitar. Our goal is to create an interface that immediately reflects the performer's intentions visually and musically without turning away from the guitar playing motion. There have been many studies in pattern recognition on the guitar. These studies recognize guitar techniques by analyzing data from guitar playing. However, these sensing techniques cannot be used directly for the purpose of this study, namely, picking state identification. In this paper, we propose a method to recognize guitar picking state by using pressure and acceleration sensors. In addition, we present an audiovisual application. Our interface consists of a pressure sensor and a 3-axis acceleration sensor. We judge the current state as non-picking, chord stroke, or single note. Table 2 shows the classification of pressure patterns. We separated pressure force into 3 categories: strong, weak, or jitter. This is a movie of strong recognition. When the pressure value is higher than one threshold, strong flag turns on. This is a movie of jitter recognition. Specifically, it indicates a state that the difference between the original pressure value and the pressure value after applying the low-pass filter exceeds a certain threshold. We determined the rotation states to be narrow, wide, or stationary. This is a movie of wide recognition. Concretely, we calculate the root mean square of the difference between the original rotation value and the rotation value after applying the low-pass filter, and then judge the state as wide if the RMS exceeds a certain threshold. This is a movie of narrow recognition. Specifically, it indicates a state that the difference between the original rotation value and the rotation value after applying the low-pass filter exceeds a certain threshold. By combining these two factors, pressure and rotation angle, we judge the picking state as non-picking, single note, or chord stroke. We informally tested our prototype interface. In this graph, each column shows the value of the pressure sensor and acceleration sensor respectively. This graph shows the result. Each column shows non-picking flag, single note flag, and chord stroke flag respectively. This graph shows the comparison between sensing data and the flag. We present an audiovisual application example. Visual expression. In the non-picking state, as an active performance, the performer can manipulate CG effects by associating the pressure with the expansion rate, and the rotation angle with the colorfulness of the sphere. Also in the picking state, as a passive performance, the interface automatically applies CG effects. For example, during the chord stroke, the RMS value affects the rotation speed of the sphere, therefore the intensity of performance and rotation of the sphere are synchronized. Sound expression. The performer can also manipulate sound effect parameters by picking. In the non-picking state, as an active performance, the performer can manipulate sound effects by associating the pressure with the dynamics effect, and small wrist shaking with the delay effect. Also in the picking state, as a passive performance, the interface automatically applies sound effects. Conclusion. In this research, we proposed a method to discriminate ways of picking by sensing pressure and rotation angle in a player's stroke movement. As a result of the experiment, 3 picking states can be correctly distinguished through our interface. We also introduced an application example which manipulates visual and sound effects through our interface. We will improve the latency in the future.